about half the probability of a marble falling in that column. Isn't that right? Because about twice the number of marbles fell in this column that went into that one. You see, the word here is probability. Can you tell where an individual marble will fall? Let's try it. Here's an individual marble. Where is it going to fall? Where do you see? Right there? Let's try it. Well, you hit it right, but you just happened to be accidental, I think. Let's try it again. You missed it. Okay? All right, you cannot tell where an individual marble is going to fall, but if you throw plenty of marbles, you can say that most of them are going to fall in here and fewer will fall over here. You see how it goes? More in the center and less out here if we threw plenty of these marbles. Now, we could do it over and over and see what the outcome is and just keep adding them up. But we won't do that now. I really want to show you how we make one of these, because I think that maybe some teachers who are watching this would like to make some like this, you know, for the classrooms. So I'm going to now get rid of the marbles over here. All right, let's hold that like that, Mary Elizabeth, and we'll go right in here like this. Right. And I'll put this down here. You can put that right over there. That's fine. The way I made this, you see, you look on the back, it's really nothing but a piece of ordinary plywood. And the trick is how to lay out these nails over here. So what we did was to do this. We took a ruler and we made some little squares like this. We laid out kind of a grid work like this. See? You want to hold that ruler for me and just keep moving it over one each time. That's right, Sonia, right here. Okay, one more, maybe right there. All right. So we got it to look like that. Now the place where you put the nails, you see, the trick is to do this. It's to go over here at the corners, like here, here, here. Now this is where we're going to drive the nails, right at the corners over here. But when you get to the next row, you don't go at the corners. You go up in the middle of the line. See, like that? And over here, you see, in the center of that segment, all the way across. And then, when you come to the next, you go to the corner once again. You see the trick? And you keep doing that all the way across the whole board. And really, you end up with the nails being what we call staggered. They are staggered. It's a staggered configuration that we're laying out over here. So the idea is this now. You see, a marble comes like this. It makes it between these two, and it hits this peg. When it hits this peg, it has to decide to go this way or that way. Let's say it goes this way. Now it hits that peg. When it gets there, it has to decide to go to the right or to the left. So let's say it went this way, and it hits that one, and so forth. You see? So every time a marble comes down one notch, it's an either or. It's like flipping a coin. It has to go this way or that way. And then it hits another nail. It's got to go this way or that way. So you have one after the other of what we call an either or choice. Either this way or that way. You see that? Right? You think you can make one like that?
Yes.
Okay, what you have to do, you have to get your hammer. You see, you lay all of that out and get these little finishing nails, and you just get it in there and just pound it out, and you get it right. And then you can use some cardboard. You can cut some cardboard strips to go out in here, you see? What I use for cardboard strips, I use something like this, you see? And I use some kind of a little blade or scissors and just go right along and cut this out into strips over here. You see how these strips are made? I put nails over here, and then put the strips like that, and then put tape around them like that. You see, now we have the nice little slots for that to go into. Would you like to have one like that in your classroom? Mm-hmm. You could really talk about probability and chance. And it doesn't cost much. It probably doesn't cost any more than your school lunch for one day. You see, it's made very inexpensively. But you can really learn some good science from it. Well, would you like to take a look at some other random events? We've got plenty. Put this over here, and let's start this way. Let's go to these beautiful little geometrical solids. These are made out of cardboard. That. I'll tell you what they're called, and I'll tell you how we can make them. First of all, we can make this one with little triangles like that. Okay, these triangles are identical. You see, this side is just as long as that side, and it's just as long as that one. I happen to have two right here. You see, they are identical. Now you can fit these together like this. Would you like to try fitting it together? We have some tape over there. Sonia, would you like to do that? You think you could fit that together and make a solid out of that? I'm going to leave it with you right here. Let's see what you can come up with. And while you're doing that, I'm going to go to this one over here. And Mary Elizabeth, look at this one. You see, it's made with 4 triangles. There's 3. There's a 4th one. We painted this one a different color. 4 sides, and they're all alike. I suppose I flip this. Let me flip it right now, like this. What are the chances that the red, this color, is going to come down at the bottom? It can't come up at the top. Nothing can come up at the top. So for this one, we have to talk about the chances of it landing with the color down. What are the chances, would you say?
1 to 4.
1 out of 4, that's correct. It has 4 sides. So every time you flip it 4 times, it's likely going to land on this 1 out of 4. So the chances here are 1 out of 4. How about this one? Incidentally, do you know what you call that one?
A triangle.
Well, no, it's made from triangles. This one is called a tetrahedron. It's kind of a big word, huh? Tetra means 4. Hedron means sided. 4-sided. Okay? Tetrahedron. What do you call that one?
Square.
Well, it's a cube. Really, it's a square on one side, huh? A cube is made up of how many squares?
6.
6, that's correct. We have 1, 2, 3, 4, and then the top and the bottom. So if I color this, different color, and I flip it, what are the chances are?
1 out of 6.
1 out of 6. And that's very similar to this over here, isn't it? You know, like when you throw dice, something like that. 1 out of 6 are the chances that any one side will come up. How about if I did it with this one? Look at the shape of this one. What do you think the chances are of the number 6 coming up when I throw it? Do you think it's 1 out of 6 now? Well, not exactly, because look, it's taller this way. You see, it's taller like that, and it's kind of slim this way. So it's not a cube anymore. You see, it's a rectangular solid. So it's not going to be 1 out of 6 anymore, you see? It's 1 out of 6 only if all of the sides are identical. And this side here is not the same as that side in area. You see what I mean? Okay, so it'll be a little bit different from that for that one. How about this one? This one is called, this is kind of a hard one now, dodecahedron, because it has 12 sides. Watch here, 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. So the word is dodecahedron. Do means 2, deca means 10, 2 and 10. You see, 12 hedron, 12 sides. The shape you see here is called a pentagon. What's the shape, what is the probability that this particular one is going to land heads up when I throw it?
1 out of 12.
1 out of 12 is correct. That is correct. If you want to make one like this, you know, it's a lot of fun. Really what you could do is to start off with little pieces of cardboard like this, you see, and you make them all join one another like this, and you have 5 equal sides, so you have to bring them in together like that. See, and when you do, the shape that you get is going to be called a pentagon. See? It's a five-sided shape. That's a pentagon, and that's the shape of this. And you take 12 pentagons, you put them together, you glue them together from cardboard, and then you have a dodecahedron. And the chances are 1 out of 12 that this will come up when you throw it. What about this one? Oh, wait a minute. Let's go to Sonia. What do you have, Sonia? You got it together?
Yeah.
That's pretty good. Green, 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 red. Very nice. So they're identical triangles. They all fit together very snugly. Do you remember what we call it? Tetrahedron.
Tetrahedron.
Tetrahedron. That's correct. Okay, we forgot to talk about this one, though. How many sides did this one have?
8.
8. That's right. They're also made out of the same kind of triangles. 1, 2, 3, 4, 5, 6, 7, 8. What would you call that? Octahedron. Okay? Octahedron. 8 sides. Right? Let's say that we paint this side and you flip it. What are the chances of this coming heads up?
1 out of 8.
1 out of 8. Well, look, it came up the first time. Again? No. I'd have to flip it about 8 times before I can expect it to come up. It came out twice, though, sooner than expected, you see? Sometimes it works like that. So I tell you what we do. Would you get me the board over there with those little octahedrons? Right in here. You see, I have some just like this big one. See, they're little tiny ones. They're made out of plastic. And we have one face is red. Now, how many of them do we have? Would you put it down right in here? How many do we have? Let's count over here. 1, 2, 3, 4, 5, 6, 7, 8. How many you got?
10.
10. So 8 times 10 is
80.
80. We have 80 of these. So let's take them out. We have 80. So if I throw down 80, what's the chances of the red coming up?
10 out of 80.
10 out of 80. That's correct. 1 out of 8 or 10 out of 80. All right? Let's do that. Mary Elizabeth, maybe you'll get me that frame right over there. That's correct. So we won't lose any of these. We'll place them right. Place this right here like this. And just throw them in there, Sonia. Here they go. We ought to have about 80. Let's bring them together like this. All right. You want to count? The number that are red, just with the red showing at the top. Count out loud.
3, 4, 5, 6, 7, 8, 9.
That's it, huh?
Yep.
It didn't turn out to be 8. It turns out to be 9. Well, 9 is almost 8, you see? So you can begin to predict that also, you see? In other words, an individual random event you cannot predict, but you get plenty of them together, you can predict the outcome, all right? Now we have one more very interesting one over here. That's this beautiful solid over here. Do you know what you call that one? Icosahedron. Icosahedron. It means 20 sides. 20 sides. I'm going to show you how you can make one. In fact, you can make one like this and hang it up in your bedroom, and it looks almost like a little jewel or something. Isn't that beautiful? Okay. Here's how you can make it. Will you get me that blue cardboard over there? You want to make one like this for your room, or maybe for your class? You see how it's made? It's really 20 triangles. You see, 20 triangles the same size as the ones we had here, like that, there. See, there's 3, and there's 4. There's 4 triangles here. 4, 4, 4, 4, and 4. 20. Now, the way that this works is, if you bent these and you fitted them all together, okay, would you like to try that? Okay. Just bend them, fit them together, and let's see if it works out. Can you go a little faster? All right. Like this. Now look what's starting to happen. starting to bring them together. Look at that. You know, it's really going to go together, isn't it? Look. Well, right here, we'll bend this in like that, see?
You want me to get some tape?
Well, you can start taping it together if you want. You see? Something like this is what's involved, okay? Now, while you're doing that, I'm going to go over here, like this, come to these. And I'm going to talk to Mary Elizabeth about these. Mary Elizabeth, look at these, and you'll see that it's just like that one, isn't it? Okay. These are little tiny replicas of this one. And you notice one side is painted. So if I flip this in some way, maybe like this, what's the chances of the red coming up?
1 out of 20.
1 out of 20. That's correct, because there are 20 sides on it, so I'd have to flip it 20 times in order to get the red to come up once. Well, it happens that I have 200 of these here. Okay? So if I flip 200 of them like this, what do you think the chances are going to be that you will have the red coming up? Out of 200, what do you expect to have?
1 out of 200?
No, 1 out of 20. But 10 out of 200, correct? 10 out of 200. So if you look through here, look at it very carefully, and you started counting these, I think you might be able to find 10. You want to try it? Just come out very carefully here, pulling them out.
1,
Okay?
2, 3, 4, 5,
6. There's a 7 one there. There's an 8 over here. There's a 9.
and a 10.
You found a 10. There it is. And only 10. You found 10 out of 200. You see? So the laws of probability did, in fact, turn out over here. You can predict how it will go if you have plenty of them like that. Isn't that right? Okay, very good. All right. Well, it appears that our time is about ended. We hope that you, like ourselves, have grown in your understandings of random events. Don't forget, individual random events are unpredictable, but the overall outcome of many random events is very predictable. That is one of the mysterious ways in which nature behaves, with the kind of order arising out of disorder. Thanks for watching, and please join us again soon. Goodbye. Hello, and welcome to Kaleidoscope Laboratory. I don't suppose that there is a person alive who does not appreciate the gift of air. The air that we breathe is so much a part of our lives that we seldom think about it until something goes wrong. And we have misconceptions about air. As you know, there are solids, liquids, and gases in this world of ours. We seldom think of air as a liquid. Did you know that air can be liquefied? And that as a liquid, it can boil just like water boils. And that were you to cool it down even further, the liquid itself would freeze into a hard block. Imagine a block of solid air. We do not have any solid air to show you today, but we do have plenty of liquid air. And that is what our show today is about, experiments with liquid air. Christopher, this represents some equipment that we can use to study air. As you see, this is a little cylinder with a piston on it, and we can press it up and down. You want to come around on the other side here and press it up and down, get the feel of it. Okay? How does that feel?
Well, it's pushing against me.
There's pressure in there. You see, and air is compressible. Okay? And it's kind of a spongy feeling, see? Now, we think that air is made up of little tiny particles called molecules. And the reason why I want to show you why we think that is this. Look very carefully at this piece of equipment. You see how this is made very much like this one over here. You see? They're very similar. Now, there's a little piston over here. See that one right there? And I'm going to pour some little BB shots right in here like this. And put the piston back on the BB shots. Now, when I start this off, there's a little battery in here, and at the bottom of this cylinder, there's a little bouncing bottom. There's a little motor here, and it gets the bottom of the cylinder bouncing up and down. And that's going to make the piston come up, just like this one over here. Now, watch how this goes. All right? See that here? Now, watch. I'll press this up and down. See my hand pressing it up and down. Then over here, I'll press this up and down. See what's happening here? That's right.